Problem 16.40. In this problem, a transistor with a height of 0.4 centimeters and a diameter of 0.6 centimeter is mounted on a circuit board. The transistor is cooled by air flowing over it with an average heat transfer coefficient of 30 watts meter square Kelvin. If the air temperature is 55 Celsius and the transistor case temperature cannot exceed 70 Celsius, we need to determine the amount of power this transistor can dissipate safely. We need to disregard any heat transfer from the transistor base. For this problem, we could treat the transistor as a cylinder, something like this. Notice that the exposed area to convection is going to be the surface area plus the cross-sectional area. So the total area that we're going to have is going to be pi dl, the surface area, plus the top cross-sectional area, pi over 4 d squared. The total area exposed to the fluid is equivalent to 1.037 times 10 to the negative 4 meters squared. For this problem, we do not have any radiation, therefore the only method of cooling is going to be convection. Therefore, the amount of heat lost by convection is going to be equal to H, the area, Ts minus T infinity. So we substitute the values that we have. We have for the value of H, it was given to be 30 watts m squared Kelvin. We calculated the area to be 1.37 times 10 to the negative 4 meters squared. The temperatures that we have, it says that the surface temperature cannot be any higher than 70 and the fluid temperature is 55 Celsius. And we find that the amount of heat lost by convection is equal to 0.047 watts. Since this is the amount of heat lost by convection, that is the maximum amount of heat that could be dissipated or created by the transistor in order for it to operate safely.